I'll just I'll just record. It's okay. All right. Hello, everyone. Welcome to our first chat with the scientist for the year. Still letting a few people in. So we have Gioia and Trent here with us to talk about anything you might want to know about space crops, any questions you have about space crops, space exploration, the particulars of your experiment. And we'll keep an eye on chat. And if you want to ask the question in chat, that's great. If you want to unmute and ask that way, you can go ahead and do that. But I think Gioia, Trent, does this sound good to you? If I pass it over to you, you might want to give a little bit of an overview of what's new in the world of your world of space crops.
Oh, you can't hear? All right.
No, I can hear. Mrs. Cates was saying something, and I don't think we could hear her. But
Oh, okay.
yeah, no, I'm happy to give a little bit of what's coming on up, and what Trent can maybe talk a little bit about what's going on, and then we can get
Yeah.
get
What's
questions.
growing on?
What's growing on? Yeah,
I like
That's your
that. What's
jam
growing
right
on?
there.
yeah, I did good that day. So, well, I'll give a start. So I've got, something really exciting happening at the end of this month, at the beginning of next month. Oh, there's a whole class of folks. Hi, guys. And so we are getting ready to launch our Advanced Plant Habitat PH07 experiment. So this is our lettuce to the space station. Yeah, I feel ya. We're excited. This is going to be in the advanced plant habitat, so not veggie. This is going to be in veggie's big sister growth chamber, where we can actually control the water and we can control it differently in different sections of the root tray. So we have a whole tray that gets put in this, and we're growing the lettuce, and we're going to actually have four different moisture conditions. Oh, hey, everybody. So great to see you here. So we're going to have some lettuce that's going to be happy, well watered, hopefully. Then we're going to have some lettuce that's going to be totally flooded. Then we're going to have some lettuce that's going to be totally drought stressed. And then we're going to have one that's going to be happy and well watered for a couple weeks. There'll be three plants in there. And then we're going to shut the water off and wait for the plants to wilt, and then we're going to add water back and wait for them to perk back up again. So we want to try those four different moisture conditions and see how it impacts how the plants grow, how nutritious they are, and also their microbiome, all the microorganisms that are associated with those lettuce plants. And we actually have little barriers between the plants over this tray so that they don't touch each other with their leaves, because they can contaminate, each other's microbiomes that way, or at least share the microbiomes that way. So we want them separate. So their roots are separate, their shoots are separate, but they're growing in the same growth chamber. And we'll be able to really see how this different water impacts, not just those plants, but longer term, this microbiome, this microbial ecology that happens. So we're real excited about that. So that's launching. It was supposed to be right around Trent's birthday, which is
Halloween,
Halloween,
yeah. Yep.
but now it looks like it's moving till November 1st or so. So we'll
Somewhere
see,
in there.
somewhere in there.
So
And
so
then
what I heard is Joya is devising ways to torture plants
torturing
and
plants. Yes.
measure the microbes and how they change. Is that about right?
That is right. But
Yeah.
torturing plants for
For
science,
science.
Yeah.
For
not just for
science.
fun, So we want to torture plants for science. And then we'll get frozen plant samples back, and we'll do a lot of analysis on them. So
And
that's
the
going to
goal
be
is to
growing.
sort of understand what when they're stressed, what microbes kind of come up and maybe help, or what is the goal?
Well, the goal is to figure out what's the best way to fail. because we know our watering system's probably going to fail. And you
Yep.
guys have all had watering challenges, right? You go away for the long weekend and your plants run out of water and you come back and they're all wilty. Or, you give them too much water and they're a bit stressed out that way. So we want to understand, and we've seen this a lot in spaceflight with veggie, because remember, veggie is kind of a passive system. So the astronauts are just adding water like you are. But in the future, we're probably going to have more automated watering. So we call that an active system because it's controlled. But we want to understand what's the best way to control it. Is it better to fail with it off, or is it better to fail with it on, for the long term of your whole lettuce growth system? So it's trying to understand, how does it impact the plants in the short term and the ecosystem in the long term?
Yep.
So
And
that's the next exciting thing for us, I think. I don't know what else we got going on, Trent.
we we are still building the next generation crop production system. We're working with a team at Utah State University, and they're devising a way using active watering, just like Gioia is talking about in advanced plant habitat. And they have a peat system that that they think will work for long duration space flight, where you can actually plant the plants, grow them, harvest them, and replant, and continue that cycle up to 10 times.
And you
So
say
that would
Pete, is this some guy named Pete, or what kind of Pete is this?
Yeah. Sorry, that's actually a good point. This is peat, which is it's a organic substrate that you get out of like peat bogs in Canada or other places. So there's different types of peat, and this is a long fiber peat which holds together and will form a sort of a root structure, and it will have a microbiome. So as Joy is talking about a microbiome, it's going to have a microbiome that will break down the roots to allow new roots to grow. So it's going to be a whole ecosystem in there, and we're really kind of questioning the food safety about how do we know that it's going to be safe to eat. How do we make sure that it's going to keep pathogens out and things like that. So they're making really good progress. There's another team in Wisconsin at a place called Sierra Space, and they made advanced plant habitat and veggie. And so they have a system that's using aeroponics and hydroponics, and they're I think we're in October, so they're about 10 months into their design and test and build, and so we're going to see how that works out. And these two different designs will be we're hoping to get a procurement in place, have them build some flight units, and once we get Ohalo on station, we'll test the two different ways to grow our crops, and we're going to try to pick the best one for when the astronauts go to Mars. So that's what we're working on.
And we should say Ohalo because that's kind of interesting. Everybody's like, "What's Ohalo?"
Oh,
So
hollow.
Ohalo is, yeah, kind of like I guess the daughter of veggie and APH, perhaps. I don't know. That starts to get weird with the analogies, but Ohalo is the next crop production system. So veggie's more like an astronaut garden. It's very simple, lights and fans. APH, Advanced Plant Habitat's a plant physiology research chamber. So that's the one with all the sensors and control systems. Ohala is going to be somewhere in between. Won't be as complex as APH. It won't be as simple as veggie, but it's a crop production test bed instead of a research system. So you need different parameters for production than you do for research. Research is like every possibility that you could want, right? Oh, I'm real interested in high temperature, low temperature, high humidity, low humidity, all these different possibilities. And, so you can figure out and investigate. Production is a much narrower constraint of your environmental conditions because we kind of know plants grow really well at, this temperature range, this percentage of humidity, this CO2, et cetera. And so we can narrow that in. We don't need all the possibilities. We just need a narrower set for production. So we can narrow that in, which means we don't need all the controls that we need for APH. So we can actually do things with less control systems, which means we can have more space for growing plants. So Ohalo is actually going to have a lot more area to grow plants than veggie or APH. Doesn't have as much height, but it's got a bigger footprint.
Yeah.
So we can grow more plants, hopefully. And the name Ohalo is pretty cool. So our colleague, former colleague Ralph, came up with this name because this was a site, it's an archaeological site that it was named after, right on the edge of the Sea of Galilee there, where they discovered evidence of the first cultivation of plants ever, like 23,000 years ago, I think, something like that. So a really, really old archaeological site. So the actual, site or the village was Ohalo. Then the archaeological site was Ohalo 2, and then we are going to be Ohalo 3. So the first cultivation on Earth. So,
Yeah, and I think Ohalo was 23,000 years ago.
Ahora las 4. Después de la siembra que tenemos en el salón.
okay. Yeah. So I think that's pretty much our updates from Kennedy Space Center. But yeah, we would love to take any questions anybody has.
I had one going back to what Trent was talking about using the peat. What's the rationale there? What do they think to use the peat? Did you say for multiple harvests?
Yeah, so the peat system, the peat doesn't really contribute nutritional content to the plant, so it's still hydroponic. You still need fertilizer, but it provides a way to hold the air and the water and the fertilizer in the root zone. And because you have the microbiome there that can break down the roots, you're able to grow the plant. It puts the roots in, it will grow. You can harvest, you can reseed, right, replant, and the microbes will help break down those roots that are in the peat system while the next plant is growing.
Mhm.
So they've tested this and they think they can get 10 cycles out of it. And so they're going to be delivering us some prototype hardware, I think, in just a few months, and we're going to hopefully get some time to test it out and see how it performs with our tests in our chambers.
Very cool.
Great
Okay, we have
question.
some questions coming in on chat. We're participating in the varied media experiment. What information are you looking for from our data? Okay, so the idea of the media experiment, this is where they're testing arsenite, which we had been using historically, and we're trying something a little different this summer, and this year is a 50-50 mix of perlite and vermiculite. And Gioia, maybe you want to say a little bit about some of the challenges that you've had and that we've had with arsenite and why that led us to look for trying something a little different this year and then still comparing it to the baseline of arsenite, what we had been going with.
Yeah, yeah. So this was an unexpected surprise and not a very happy surprise. Earlier this year, we were doing the testing for that experiment that I was talking about at the beginning, the APH07 experiment on our lettuce. And we did our first pre-flight test, which is called a science verification test, where you test it out in the APH for the first time, and everything did really well. We were like super happy. We wanted to tweak a few little things in terms of our moisture levels for the different conditions. So we got set up and we did our next test, which is called an experiment verification test. And this is like the full dress rehearsal for flight. This is like what you do when you're ready to flight. You got all the details ready. So we did our next test, our experiment verification test, and our plants grew horribly, like terrible, terrible growth. They were really small. They just didn't grow very well. They were really stressed looking. They were dark red. And we were like, what the heck's going on? We didn't change very much. Well, we looked back and we had gotten a new order of arsenite in, and we hadn't got, the old order, we got a giant pallet of this stuff, so huge amount, lasted years and years and years. So we hadn't gotten some since 2018, which is probably, as old as some of you on here are. And so the new order came in, and we hadn't really thought anything of it. It was the same brand, it was the same media, this Turfus Pro League Elite. And when we started testing, that was the problem. It caused our plants to not grow very well at all, to be very stressed. And what we found out, we did further testing, we did chemical analysis, and it showed that this arsenite, which is a clay material that's dug out of the ground and then it's baked and then it's pounded up into small fragments and then it's sifted to different fractions. Well, the clay that they were digging up had a lot of calcium sulfur or calcium sulfate in it, which is a mineral called gypsum. And that was getting out of the clay into the solution, and it was just causing our plants to be really stressed out. It also changed the pH of the water that's in contact with this clay. So not only were we getting minerals coming out of this clay that really hadn't provided any minerals previously, but we were getting a change in pH. So both of these things caused a lot of problems with the plants. Well, long story, but we went, back and forth with the manufacturers, and they're like, well, all the stuff we're digging out now is of that pH. And we asked if they had old stuff, and they didn't really. And, now they're moving, they're digging somewhere else. So they're digging it all out of the ground. And so it's a natural material. And just for some reason, the batch that they've been digging up for a while has just not been good for growing plants in. Now, this stuff is used on baseball fields. It's the stuff between the bases, right? So they don't care what the pH is, right? It's used on other sports fields or golf courses where they just put it down and, kind of seed it in. So it's not used by a lot of people as a material just to grow plants in all by itself. So not everybody's having this issue, but we're having this issue. And we told Nathan and said, you better look at what you got, because if you're having the same issue, it's going to do, a really big problem for Growing Beyond Earth this year. And Nathan looked, and lo and behold, they had the same material. And so we've been working with the company and working with other people to try to fix it. And so far, we're still not there yet. We're still trying to find a new solution. They have moved to a slightly different location where they're digging this stuff out of the ground, and it seems a little better. So maybe by next year they'll be back in a good spot, and we can just order a whole bunch and hope that it lasts for a while. But for this year, it was not going to work for Growing Beyond Earth. So Nathan and his team revectored and came up with some new approaches. So thank goodness. Got to be flexible in the space business because things change quickly.
Yeah, and Joy and Trent too, is that do we know, you may have said it and I may have missed it, but do we know where that, and I tried to find out too and I couldn't find it, where the mine is? I'm sure they probably have multiple mines where that company is pulling out this clay or arsenite as we're calling it.
Yeah, I think
Even
it
the
was in
state, we
like
don't know, do we?
Mississippi
Mississippi?
or Arkansas, but yeah, I
Okay.
can't remember. It was somewhere in that region of the country though. Yeah.
Okay. Yeah, and then the perlite and the vermiculite that we're using this year, that all the trials are using, have a lot of the similar qualities that arsenite does. It's inorganic, meaning there's nothing alive in it. It's light, they're airy, so it's good for root gas exchange. So that was our thinking here at Fairchild, why that might be a good alternative. So we're giving it a shot, see how it goes.
Yeah,
That's what
and
science
that
is,
was
right? Experiment,
one of
try
the
it.
things I had tested, in before Veggie ever flew in 2013, 2012. I was doing tests with different media. And so perlite and vermiculite mixed was actually one of the ones that I tested, and yeah, different types of material. So, the veggie plant pillows are designed for whatever you can stuff inside them. So it doesn't have to be the turfus. So there's certainly no reason that we couldn't someday fly something like perlite and vermiculite. You got to be real careful because it's dusty and that could be a hazard. And that's why we have a lot of precautions in the procedure for you all working with it too. Make sure you try to do it outside, or you can wear a dust mask, or, wear some goggles so it doesn't get in your eyes, those types of things. But um, Yeah, even the arc light has some dust, so that's
Yeah.
always a concern.
Yeah. All right. Well, we have another question here. How does the International Space Station use the oxygen from the plants? So this is getting into the bioregenerative aspect. It's
Yeah,
cool.
it
Good
doesn't
question.
really. They don't produce a lot of oxygen because we don't have a lot of plants growing at any one given time. I think Joy, correct me if I'm wrong, but you to really produce the oxygen needed for, say, one astronaut, you need about 20 square meters of plants
It's
growing, and
huge.
that will produce.
Yep.
Yeah, so I mean, you could stack it, right, like vertical farming, so you can stack it into pretty tight volumes, but it's still a significant amount of plants. It's I would say it's probably about a container, right? So I think a
Yeah, I
container
think I
can be square meters.
calculated once it was almost 200 veggies. So,
Yeah.
yeah.
Right, and veggie's not a very efficient form factor, right? So that's I think you can get 20 square meters out of a container farm. So it's it's a not an insignificant number, and so and then it's 50 square meters. I think if you were to provide the full vegetarian diet for an astronaut. So if you think about long duration space flight, once you start producing a lot of the food for the astronauts, you're already you're gonna have an oxygen problem actually, right? So you're going to be
Mhm.
producing a lot of oxygen. You're going to need CO2 for the plants. So it's going to be actually a fun problem, a nice problem that we might have in the long future.
Can you guys tell us how they are producing? Because the plants are not going to be producing enough oxygen, even even going forward. We would have to have massive farms, right, to produce enough oxygen inside of a moon base. It's just not enough. So we need other ways to create this oxygen. How are they
Yeah,
doing that on the how are they doing that on the International Space Station and moving
yeah.
forward?
We ship up oxygen tanks. We ship up actually nitrogen tanks too, right? So a lot of people don't think about the nitrogen. We actually ship up nitrogen, and so they do it that way. We do capture the CO2, uh, and there's a couple different ways that we do that. I'm trying to remember. There's a experimental way that we're looking for exploration, which is more efficient. But essentially, they'll capture the CO2 and then they'll vent it out. I think is what they do. It's been a long time since I looked back at or we call it ECLS, environmental control systems. Maybe Joy might remember, but they're basically chemical methods.
Yeah, there's some scrubbing, right? And um, but then you got to change out filters and scrubbers and things. The
And you
space
can use
shuttle was
water.
cool because the space shuttle used to make, well, it made water, right? Because it had hydrogen and oxygen, so it made water. Yeah, it didn't make oxygen, but
And the
yeah.
nitrogen is an interesting point too that I think people might not think about, that air is not primarily oxygen, that it's mostly nitrogen, so you need to have that. And too much oxygen is not good for anyone.
Definitely not. Becomes a
Actually, a fire
flammability
hazard.
hazard. Yeah.
Yeah,
Yeah.
yeah.
And that's a real big concern in space. So it's 21%, right, Trent? They
Yep,
keep it
you
at
got it.
21%. When we go to lower atmosphere, lower pressure atmosphere, so when we go to the moon or to Mars, we're going to be operating at probably reduced pressure. And there's a reason for that, right? Because if you have to go outside in a spacesuit and your spacesuit was at one atmosphere, you wouldn't be able to bend your arms. Like you wouldn't be able to walk. You couldn't do anything. So the spacesuit is at this low pressure so that you can actually move because
Move.
otherwise you'd be a giant, statue of an astronaut.
It would
And
be pressurized so high. It's just think about blowing up a balloon and then having it at such high pressure you can't bend it, right? So that's
Mhm.
essentially what your spacesuit is.
So we have to be at lower pressure to go out on extravehicular activities. They're called EVAs. And to go from a high pressure to a low pressure, you have to change the oxygen concentration in your blood. Otherwise, you can get some really painful disorders and things that happen, like the
Yeah, the
bends.
nitrogen.
Yeah.
So the nitrogen, as you
Oh,
change
that's right.
pressure,
That has
the
to come
nitrogen
out.
will either go in or come out depending on which way you're changing pressure. Divers know this. When we go down, it's no problem, but coming back up as the pressure is relieved, the nitrogen will come out of solution, out of it basically is in the blood, And if you come up too fast, you don't give it enough time to come out and for you to breathe it out, and you can get these little nitrogen bubbles, and they'll get caught up in your fingers and your toes and the capillaries, and that's why we call it the bends, is because it hurts when you bend your appendages. And so you have the same issue going out for spacewalks. Is it's a pressure change, so you can get into your spacesuit and go do useful things. In addition to that, think about the structure that you need to hold that pressure. If you reduce that pressure, you have less risk. You're going to have lower leak rates and less structure that you need to ship to the moon. So there's a lot of advantages to going to lower pressures when you're in a vacuum. The problem is now you got to increase the oxygen. That way the human can get all the oxygen that they need to do their activities inside the hab. And so, that's why you'll see sometimes if you look at exploration atmospheres, you'll see why do they have oxygen at 30% or 27%, right? It's because we're maintaining the oxygen at the same level that the human needs it.
Yeah. Yeah. So that will be different when we go to the moon or Mars. We'll be at this lower pressure, so they don't have to wait as long to go outside in their spacesuits, right? Because it's like a long difference, right, between pre-breathing.
Hours.
Trent, yeah.
Hours. It's like I can't trying to remember Bruce's talk. He did the calculation.
Yeah, it was a good
like 6
talk.
hours. 6 hours of pre-breathe. You're in the airlock,
If you have
pre-breathing.
to
Several
come
hours.
from one atmosphere versus like half an hour or something if you're just at lower pressure. So we're going to be growing our plants at lower pressure, but we'll keep the oxygen level a little higher. So that will be okay at the lower pressure. But on the space station, they don't want the oxygen to go too high because, again, it could cause fires, and that's really bad. Fires are bad.
And the space station is at 1 atmosphere. It is at Earth's atmosphere. I think our vehicles, when we're on the way to Mars, we're planning on those being at Earth's atmosphere for the time being.
Yeah, so when the astronauts do those EVAs outside the space station to fix things or clean things or attach new elements, they have to spend a lot of time in the airlocks.
Yep.
Going out and coming back in, getting the nitrogen out of their blood, like Trent said. So I see some good questions about pH and that's really
interesting, huh?
interesting, Lisa. And actually that makes sense to some extent. So plants, the favorite pH of plants is not neutral, like a lot of people would expect. It's not 7. It's actually 5.6 or so. That's really the ideal range for plants to take up all the nutrients that they're taking up out of the fertilizer. So that's kind of the sweet spot right there. And you can go a little higher or a little lower, but plants don't really want to be up around pH 7. They don't want to be around pH 4. So they really want to be in that, 5.5 to 6.5 range. So it's good that you see the pH kind of going down to that range. And the conductivity, you would expect that to increase because remember, you've got that controlled release fertilizer mixed with your perlite and your vermiculite. And so that is releasing nutrients, and that's what is increasing your conductivity. It probably is also, changing your pH a bit. The plants themselves may be releasing things to change the pH a bit because plants can secrete chemicals that, can make their environment happier for them. Mm-hmm. So that's really cool that you're seeing that. Oh, there's a great question about C3 versus C4 plants. So yes, we actually have had an investigator just looking at that this summer. Unfortunately, the experiment didn't go as well as we'd planned. So these were growing in veggie, and the idea was to compare model C3 and model C4 plants. So this is different forms of photosynthesis, different types of photosynthesis. So if you guys don't know what C3 and C4 are, you can look them up. But we had 2 grasses. The investigator is Dr. Pobudu Handakambora from Pacific Northwest National Labs. And she had 2 different types of grasses, and one was a C3 grass and one was a C4 grass. And she was growing them in veggie. Unfortunately, the C4 grass, which is the one that we haven't grown before, didn't really grow. We had some seed germination issues, and they just failed to germinate. And they also didn't grow really well on the ground. So she's hoping that she'll get an opportunity to try that again, because that's a really interesting question, with the high CO2 of the space environment, how do these different types of photosynthesis work in that environment?
And Nathan, that's I think the next question is directed to you regarding the deliveries.
Yeah, American Military Academy. Don't recognize that, but you can email us. Everyone should have received their kits by now, but email us at Fairchild Garden. I'm going to put the address in the chat and we'll get that out to you.
Anyone have other questions? A whole bunch of kids there. No questions?
Yeah. Hey, since I got everyone here, I just enjoy it. Correct me if I'm wrong, but I wanted just to mention that Nathan sent me the list of crops that have been grown, I think, since 2015. And we're taking a look at all those crops, and we're going to be publishing that in a report soon. And I say soon because I've been trying to get this thing published for months and months. It will get done eventually, as soon as I fix all my mistakes. But we're going to get this thing published. But the interesting thing is we're gonna see how we can maybe take some of those crops to the next step, just like we did in the past. So I just wanted to mention all the crop research that's been done and all the work that's getting done this year. We are certainly using it and appreciative. And again, the answer is not in the back of the book.
Right.
Understanding how these plants grow in vermiculite is going to be important. Are there differences, right? So the question about, what are we looking to learn? We're looking to learn how the plants grow in this different media, because that's going to be potentially a measure of how robust the plant is in something different, right? And so now it's in this new media, which should be really great, but it did poorly. Well, why, right? Or it did great, awesome. Then our hypothesis that the vermiculite's a good media for this was good. But it's just important to learn that, oh my God, these plants, did poorly in this. And so we would look at those plants and wonder why they're less robust than others. So
the 49-day versus 28-day, arbitrary. Let's grow the plants as long as we can to get the most data we can. So that was based on my timeline of thinking we could get all the materials out to everyone by October 1st. And then teachers can run those experiments and be finished before Thanksgiving in the event that they're not able to get back into school. We don't want people to feel like they need to go into school during their week off to water the plants. But as I've said in other emails, it doesn't have to be 49 days. If you can run a 5-week trial of irradiated seeds, that's great data. But Lisa, specifically, if I recall, I think you did have irradiated seeds, and I was curious, and we were just curious in general about the longer duration, if we would see any changes, because we've tried the radiated seeds, and sometimes we get mixed results where the irradiated cultivars grow better, other times they grow worse. So we were thinking of growing these ones out a little bit longer and see if we can tease out some of those differences between the irradiated versus the control group.
did we answer the question about the measuring pH in media? I think Eileen had a question about that.
She was asking Lisa how she measured it. That's
to
right.
do it
So
with a pH meter?
Yeah, if you have a pH meter, you can take, there's different methods, and I think there are some standards out there.
ASTM definitely has methods. Me,
Yeah.
I got the ASTMs. You know how I roll.
Yeah, but essentially you take something like distilled water, and you can pour it through your pot of media, or you can have your pot of media sitting, in water for a bit, and then remove it, and then you can measure that solution. So there are certain standards for the volume of water to use and things like that. I'm not sure how you did it, Lisa, but if you want to share that with the group, that'd be great.
Yeah, Lisa, just following up on that, and this goes for all of us. If anyone has a way of doing things, a method where you're measuring something or measuring a variable that is something extra, please share it with the whole team. You can email us and we'll put it on the website. Other people for sure, I would think might want to be measuring pH. This is great. Thanks, Trent.
I love our standard test methods because that's how we make sure that we control the test, and this is how we verify across different places. To it's just so important to run standard tests.
Absolutely. Yeah, this is great. Thank you for this. We'll put this up on our website.
Question about compositional
Composition of
changes.
vermiculite
Yeah.
mix, a target for the media study.
Oh.
Yeah, so as I said, we were trying to find analogs to arsenite, things that have other media that have properties that are similar to arsenite. And both vermiculite and perlite are inorganic. They have a lot of porosity to them, a lot of pockets for gas exchange for the roots, and they're light. So if you're lifting things into space, the lighter the payload, uh, the better, right? So those were some of the criteria that we were thinking about as we were moving forward and trying to find some alternative to the arsenite, the clay.
Yeah, it's important to think about, when you're thinking about substrates too, you want one that's not going to contribute nutrients, right?
That's right.
So
Yeah.
having something inert is really good if possible, because that's, where our problems came in. We had something that was pretty inert and then it stopped being inert, because we got a new batch. So you don't want to add to it because we've got the fertilizer, and the fertilizer really releases the nutrients that the plants need. So the substrate is there, it's for a couple reasons. It's to kind of give the roots something to hold on to, and this is especially important in gravity and maybe less important in microgravity, but it's also to as Nathan said, to give that aeration. So you want air, but you also want moisture in the root zone. Now the water holding capacity for vermiculite and perlite is probably different than for arsenite, and so we're looking at kind of a different moisture conditions in the root zone, and that's something that we're all going to learn from this year. Um, but you also want, ways for the roots to just be able to grow in 3 dimensions. I mean, you can just grow plants in a dish or something, but then the roots just are in basically 2 dimensions. So you want
Mm.
that 3 dimensional architecture, and that's what gives you that. So it's pretty interesting to look at substrates. I mean, there are things like foams that could potentially be used. And we have flown some of these in the past, some that are a little more like a floral foam almost, or there's some that are squishier foams. There's a material called rock wool, and that's used a lot in the greenhouse industry. It's almost like fibers, almost like the insulation you might stuff in your ceilings. And that works for some plants well, but it's got some toxicity issues that I worry about. And it doesn't, it's essentially a byproduct of, it's like the cotton candy of the rock world. So if cotton candy is made out of sugar and then you spin it really, really, really fine, well, rock wool is essentially the same thing, but you're doing it from rocks instead of sugar.
Basically
And
lava, right? You
yeah,
basically
you
melt it.
melt it and spin it and make it into cotton candy, and then you're growing plants in it. And so, so that's a bit problematic. And so the arsenite was selected for space originally for a few reasons because it's porous. So it's a porous clay, and it's almost like a chia pet or a terracotta plant pot. It helps breathe, right? It doesn't have a glaze on it like a teacup or a coffee cup, but it's clay that is not cooked to such a high temperature that it is glass. It's instead porous, and so it helps trap that air in the root zone. Um, and it, in theory, is reusable. And I don't know if any of you have tried in the past, but you can, harvest your plants from it, and you can take that stuff and you can wash it out. You could wash all the roots out, the fertilizer out, and reuse it. But in practice, it's not very easy to do that. And in space, it certainly wouldn't be easy to do that. But those were some of the reasons that it was selected. But it has some drawbacks. It's heavy. It's a lot heavier than the vermiculite, the perlite, even potting soil and things like that. And so we're launching heavy clay to space. So it was never really designed to be the best long-term solution for space. But it was designed to be a proof of concept for space. And so that's what we've been using. But as Trent said, we have some other companies developing other longer term types approaches to water and nutrient delivery and oxygen delivery in space. And so we also have a fluid physicist who's been working with us on developing another space-rated hydroponic system that should work like it will on Earth. So there's a lot of interesting activity there, but we don't really have anything yet that we can roll out for growing beyond Earth. So we're still looking for options, and if you come up with a good one, it might be what we end up using. Yeah, that's a really cool question. Would a 3D filament lattice-like structure added to the pillows impact the plant roots' interactions with substrate? Um, I think we could potentially do something like that. And we've had some engineering teams look at 3D printing of like lattice structures that you could actually use as a plant growth substrate, almost like a honeycomb or, little 3D printed cubes or stackable materials. Um, the 3D printed plastics are interesting because you could potentially recycle them. And we did a project on that this past year. We looked at recycling and reprinting plastics with and without like plant material in them. So I think there's a lot of potential there. You can use geometry to try to get that air and water in the root zone. So there's something called a vein structure, which is essentially a V shape. And when you have that V shape, it pins the water down in the bottom of that V in microgravity. Just by having this V shape, you'll get water and then you'll get kind of air. So you'll get that interface. So you could, in theory, make little 3D printed little V-shaped lattices. They do get clogged up with roots. So how do you clean them? I think recycling and reprinting might be the best solution, but that requires a lot of heat. So you'd have to look at that. But I think that could be really interesting. Any questions? Any thoughts on what you might want to do for original projects this fall, winter? I mean, it's still early times, but soon you'll be needing to put in a proposal if you're going to be doing one in the spring. Mhm. I think we had some good ideas with different media, 3D printing type things. I think that could be kind of fun to test and compare. So yeah, get your students.
Yeah, we tried some of that
Have some.
years ago, remember?
Yep. Yeah, it's neat approach. There's this very cool thing. I'll just show it because I happen to have one here on my desk. It's called a gyro cup. This is something a company came up with. So this like spider-like thing. It's kind of rubber, and then you can invert it, and it makes a little pod to grow plants in. And so those types of things that could be reusable and just clean it and reuse it could be real interesting solutions to start to play with. Fungus. If you see fungus grow on the plants, well, is the fungus on the plants or is it on the top of the media? If it's on the plants, you may want to try cutting that leaf off, so it doesn't spread to the rest of the plants. If it's just on the media, you could put a little more dry media on top or disturb the surface a little bit or just scoop out where the fungus is. Fungus is a problem. Might mean you might have a little too much water, not enough airflow, maybe. I don't know.
Just depends if it's on the plant or not.
Yeah. Don't eat it. That's what we tell the astronauts, right, Trent?
Don't eat any funny looking leaves.
Yeah,
You're right.
Something funny
Yeah.
growing on the plants. Don't pick that one.
Alondra, you may well have seen it on the perlite. Just the perlite is white. I would be surprised if anyone just has perlite that's completely white by the end of the trial. So I think how do you feel about that, Joy and Trent? That it's pretty much unstoppable. As you said, you can disturb the surface, maybe add another layer of if you have some extra growth media to cover it up, but we really just can't stop it with the humidity in the chamber and we try to minimize it with the flow of the air with the fan, but
yeah, you
and
got
it's very
fungus
visible.
and you got algae too, and that,
At the algae too, right?
Anytime you have water, nutrients, and light on like a wet surface, you're going to get algae until your plant gets big enough to maybe block the light to that surface. So a lot of times what we'll see like algae or microbial growth on the surface of the pots when the plants are small. And then when the plant gets big, it shades it out, and at least the algae tends to go away.
If I could mention something really fast, if possible.
Sure.
I think it was 3 or 4 years ago. My school was also doing research with GB, and we had like a really big mat of algae like growing underwater in a tray, and that was just 1 year. But we had to keep changing out the water every time. That was like the only major like not mold, but I guess just like major growth that we had one time.
Yeah, that's crazy. But sometimes, the building you're in, like if the ducts haven't been cleaned in a while or you're near something, you'll get these like we've had some certain plant growth chambers and they constantly contaminate the experiments. It's just something in the air and we can't get rid of it at a certain point. You can try to clean things down in between experiments. But yeah, sometimes you'll get growth like that, and it's just like, what do you do? It can be overwhelming. A little bit of hydrogen peroxide can help too. That's what we do use here. We'll get, dilute hydrogen peroxide, and you can mist it on like the top of the soil with a little squirt bottle. You can mist it on your mat. That might help cut down on some of that. Try not to get your plants, but you could just do around your plants.
Yeah, that's a little risky because if you do too much, then you can impact basically the redox potential of the whole system, right?
Mm-hmm.
Redox is how reducing or oxidation the whole system is, and it will affect the microbiome in the plants.
Yeah.
How do we know that there are air pockets in the growth media? I think my quick thing is that if you don't compress it, that helps when you're planting the plants, just to put the potting mixture, the media in very loosely. Do you guys have any other ways of how you might be certain that you have enough airflow going through once you've already potted your plants, maybe?
Yeah, it's really a matter of compressing, and as you see with the perlite and the vermiculite, they're pretty fragile. So if you squish on them too much, you'll start to break them. You'll get more dust and it'll fill in all those air pockets. But, you can pat it down gently. But and even even if you pat it a lot and you don't have, a lot of air pockets, you'll still probably have enough, because they are porous media themselves. So I think you'll be fine either way. With APH, with the arsenalite, we really tamp it down when we're filling the root trays. Um, they pack it pretty tightly because you actually want the particles to be contacting. You'll still get air pockets between the particles, but you want them to be in contact so you get good distribution of water, because otherwise the watering doesn't work as well in space. So they actually have a really big packing sort of protocol they use.
Is that just the cohesive nature of water? It just balls up in the pockets and doesn't
Yeah, or it
distribute?
goes, yeah, it would just be asymmetrical, and so you wouldn't get the uniformity of the water in there. Yeah, and it makes it hard to control because that one's controlled watering.
I've
So,
seen water do really, really weird stuff in pots in different places and creep out and escape and found it weird spots. So yeah, it's water is a challenge in microgravity.
it looks like, has anyone tried to use a programmed watering system with Growing Beyond Earth? And if they could program a Raspberry Pi for it, go for it. That would be great. I think it would be really interesting to see that work. I think maybe some people have tried. I'm not sure.
Tengo a Onyx, Alondra, Joel y Brian.
Not sure about those comments.
Um, oh yeah, watering system. I would love to see. That's a great spring experiment, right?
And then you
Okay.
could compare like the manual watering to automated watering and compare your harvest at the end. If you grow them the same duration, it'd be really interesting to see what differences you would get there. And I think you could certainly do, whether it's a timer or, something, you just want to be able to keep pace with plant growth.
And you
So,
got to watch out for leaks, and
Mm.
yeah.
because what if you have failures, right? And Gioia, we've had failures in Greenworks in a few places with automated watering systems
Mm-hmm.
and leaks. You can really so think about secondary containment
Yeah,
and think
put
about
everything in a big tray or tub that'll catch the whole thing if your water system
your
lets go.
whole quantity of water. Might pump out if there's something weird that happens, and we've had leaks. Automated watering is awesome,
Yeah.
but
Well,
yeah, it's
yeah.
also a learning opportunity.
Yeah.
I mean, it's just like at home if your water heater goes or your air conditioner pump fails or something, you can get a flood. And if it happens over the weekend when you're not in your classroom, it could be a very exciting Monday morning. So always good to
Waterloo
have.
Secondary is asking about insects. That's interesting to me because the perlite and the vermiculite are
Mm,
the perlite's just glass, right? Volcanic glass, and the vermiculite is like magnesium
Mica
ammon
or something, right?
yeah,
Isn't it?
aluminum oxide, I think. Might be a sulfate, but it's interesting to me that the insects would be attracted to that, maybe just attracted to the plants themselves.
It could be the color or the light, the reflection of the light off of them might be somewhat more attractive, because it would be a different color than the arc light. That's all I could think of.
Hmm.
Yeah, that's very interesting, but it's good that you put netting around. The other thing you can do is, they sell, you can get like yellow sticky cards or blue sticky cards, or you could even just take, like a yellow cup. I think they even sell like yellow Solo cups or a yellow cup and put like Vaseline on it or something, and
Hmm.
insects can get attracted to that. You can make your own insect traps. That yellow basket right behind you, Nathan, that'd work well. You put Vaseline on something that color, and insects tend to get attracted to yellow, light blue. So
Hmm.
you might think about making some insect traps to keep them out too.
That's a good idea. A slightly dimmer light setting I mean, I guess that's on me. That was based on the light settings that I was using in our growth chambers to test all these potential experiments this summer. So I rolled out what the light settings that we were using this summer. That's the only reason for that. Kids want to know why the light recipe never has green light.
We want green light.
Green, yes. Plants will use it, right?
They
Absolutely.
use
Plants
green
want
light.
green light. Yeah.
I
Yep.
mean, but the minimum, Joy, the minimum necessary is red and blue, right?
Yeah, I mean, those are the minimum for powering photosynthesis and good kind of water relations. So green isn't really needed. But green is nice for us to like look at the plants and go, oh, they look like plants. So in
Some
veggie, we
plants use
often
green though,
have
right?
green. I mean, they will use it, but they don't necessarily need it.
Need it. Okay.
So it falls in kind of a, an area of the spectrum where they have certain pigments that can capture it. Much of it is reflected, some of it's transmitted through, and then they do capture some of it and they channel it down through different, electron transfer chains, different cascades, but they will use it. But it also, it's nice for human vision because you can tell it's actually a plant, looks green, or if you have, disease, you can see it better. It's good if you have fruit ripening, it's easier to see. You can use white light, and so we use white a lot instead of green to do that. Veggie doesn't have white light, but APH we use white light a lot to give that green component as well. But no,
Ohio will have some white LEDs. It's a lot of
yeah,
white LEDs. So
but we definitely use green. So yeah, I think this year it wasn't if it's not in the light recipe, but the purple light's pretty compelling for a lot of people too. It's
I
sort of
I
And
sucks
just
you in.
talked
Gioia,
to I talked to
go ahead, John.
the one of the Canadian astronauts just the other day and reconfirmed what I had already heard is when Veggie was on in Columbus module. Columbus is the European module. They would call it because of the purple light. They called it Club Columbus, like a disco. So
Yep.
David St. Jacques confirmed that again. So
And regarding the green light, Joy, you alluded to it that the white light, and we do have white light in our veggie units that went out. That was part of the baseline, the control lighting setting. So you all that are growing it and you have white lights, white LEDs shining, you are getting a little bit of green light, but it's not what your kids are
Yeah.
expecting. Maybe your students when they see, specific red lights and specific blue lights. You're right. There are no, unless you're doing the radish trial, which is specifically to test some different ratios of light with green light in there. You won't see any green light LEDs being lit up. Unless in the fall or in the spring you want to get in and change that as a
Yeah, a
as
good
a light recipe.
parameter to
well,
change. Remember, you can only
you can
change one thing.
at a time,
Yep.
but you can tell your students that a lot of the astronauts did enjoy having the purple light. Um, I remember talking to one of the astronauts, Butch Wilmore, and I said, well, we were going to put white LEDs in there. He says, oh no, at least make it crew selectable so we could have purple light. So I think they liked it for ambiance. Some of them, not all, right? They're people, so there's different preferences.
Yeah. Maybe this can be the last question from Lisa. This is something that I was thinking about, and I thought I'm glad, Lisa, you brought this up. Stem lesions observed on the perlite vermiculite, but not on the arsenolite. Makes sense if the perlite is glass, so volcanic glass. You might
It's
maybe
sharp.
Joya Trent, you think that might be. I don't know that the vermiculite would be doing that, but the perlite, I would think,
Yeah, I wouldn't think
would
it'd be
damage it.
coming from vermiculite, but the perlite, it can be sharp, and so it could scrape or scratch the side of the stem. And generally plants will kind of heal up those, but it could be something that it could potentially be a path to introduce more disease. So that could be a really interesting outcome of the study. If you see these plants just are healthy or less healthy or have more disease, then we know, okay, well, we can't really do that. Let's go back to the drawing board and think of something else. So,
Hmm.
yeah, very cool. Well,
Right.
yeah.
Well,
Thank you
great.
all. Yeah.
we will leave it there, and we have more chats with the scientists to come. So this was a really interesting one, fascinating. This was my first one, obviously live with you all. So Gioia, you were great. Trent just had to drop off, but he was great too. And all you teachers and students, you guys are great too. We really thank you.
Yep. Come with more questions next time. So
Yeah.
we'll see you next month.
Bye, all.
Take care. Bye bye.